How's it going? MoNaCo here. Welcome to our 8th unit. We'll be studying kinetics and equilibrium. It is our first lecture video for you to take notes in your pack. We're going to be covering reaction mechanisms today. And so at the end of this video, you should be able to identify some unique vocabulary related to chemical reaction rates. So let's get to it. Our lead-in is that we know that chemical reactions happen. Duh, they do. But can we manipulate them? How can we make them go faster or slower, and why? Okay? So we're going to talk about the steps of reactions and rate determining steps. We're going to talk about opportunities to make those reactions go faster and slower in this lecture. Okay? Well, let's check it out. First thing you got to do is start writing down some words on blanks. For kinetics, which is the study of the rates or the speed at which chemical reactions occur. So we've studied the types of chemical reactions, and now kinetics, we're going to be studying how quickly they go or how slowly they go. A reaction is the breaking and reforming of chemical bonds to make new compounds as products. So for any reaction to occur, bonds have to first break and then reform in order to create the new products. Let's see what we got next. Here we go. Reaction mechanism. The analogy I like to make like this is it's like a series of steps that you have to take in order to get from your bed in the morning to the school and the class. So a reaction mechanism is a step-by-step process. It's like the order of operations for a chemical reaction. Order of operations in mathematics, PEMDAS. Chemical reactions, there are not exactly a sequence, but there are certain criteria of things that must occur for the reaction to take place. Normally, we have reactants on the left-hand side of our arrow, and we have our products on the right. And the mechanism is just like the recipe. How do you get from lying in your bed to being in the class? Well, there's a sequence of events that has to happen. When you bake a cake, we must follow directions. You can't omit any steps, otherwise you don't get a cake. And you can't change the order of the steps, otherwise the cake doesn't come out quite right. Like you can't heat it and cook it in the oven before you mix it all together. It wouldn't make any sense. It wouldn't be a cake at the end. And you can't omit any reactants or ingredients. Like if you leave out the eggs or the oil or the butter in the cake, it's not going to be the same. Okay, so mechanisms are those processes, step-by-step, order of operations of how you get from our reactants to our products. And it all happens inside here, in this magical arrow. This arrow represents all the things that happen in kinetics and rates. So, we're going to talk about how each of these chemical reactions are examples of fast or slow reactions. And we're going to know how the relative rate of reaction is significant. So, rusting. Okay? My car, 10 years old, it's just now starting to get some rust. So I would be inclined to say that is a slow reaction. How do I know that? I explain it. Well, it's because if iron rusted quickly, we wouldn't make cars and buildings out of it because it would be useless to us. So that's why we know rusting is slow and it takes some time. Alka-Seltzer in water. As soon as the Alka-Seltzer touches the water, it starts to bubble. So that is a fast reaction. Explain why knowing this relative rate of reaction is significant. Well, knowing how fast a reaction is important. If you've got a headache and you need your Alka-Seltzer, you want it to be quick. You don't want to be waiting 3 hours for your headache to go away. You might as well go to bed. You need a fast reaction for that Alka-Seltzer to dissolve. Styrofoam decomposing. I hope you know that this is the truth. Those styrofoam trays at lunch, they go in the garbage can, they go into a landfill, and they'll be there for like 30,000 years. Styrofoam decomposing is a very slow reaction. Why do we use styrofoam, you ask? Well, because it's a slow reactor. If you put food on a styrofoam plate, the food doesn't react with the styrofoam, which is good for you to eat the food, but it's not good for the landfill and stuff because that styrofoam plate or the cup or the bowl or whatever can be there for like a long time because it's a very slow reactor. Weathering of rocks. Hope you remember from earth science is that weathering is a very, very, very slow process. We humans can do things to make it go faster, like put more acid rain into the environment that makes rocks erode quicker, or physically break up the rocks in quarries and mines and stuff. But we're talking about natural weathering of rocks. It takes on the orders of millions of years to do. Bleach removing color. Bleach. So I get a bleach stain on my pants. It removes the color from my pants. Happens in like one wash cycle. That's pretty fast reaction. And it's a good thing too, because I want the stains out of my clothes quickly. I don't want to have to wait a week of my pants being in a soak bath so that that little tiny ketchup stain disappears. I want that to be fast. Okay? So some reactions are fast, some reactions are slow. But what determines the rate of that reaction? Why are some fast and why are some slow? Well, the number of steps, obviously. If the reaction takes more steps, it's going to be a little bit slower. And the rate determining step is the slowest step of the reaction. It's the most important factor influencing the reaction rate. I was actually asking my students this morning, in your reaction to get out of the house in time to get to school, what is your rate determining step? What is the slowest thing that you do in the morning? Many students said take a shower. Some of them spent 45 minutes in the shower before they got dressed and ready to go to school. That's their rate determining step. That's the slowest step in their sequence of events to get out of the house. So the slowest step determines how long the reaction takes. Let's see what else we got. Now, at this point, we don't have any practice packet to work on. Let me show you. Your practice packet this time looks like Kinetics and Equilibrium, Unit 8. You should identify those key vocabulary related to kinetics. Rate of reaction, reaction mechanism. Relatively simple little lecture here. So please continue on with the videos and be ready to do some Castle Learning quizzes as well as some practice pack reading material. You could actually get started in here already because the first assignment is about kinetics in collision theory and it requires none of this prior information to understand. It's a reading and comprehension question assignment. So thanks for watching. See you later.